All right, we're going to talk about solving systems of equations using tables and graphs. So first of all, we better know what a system of equations is. Systems of equations is a set of two or more equations. The solution to a system is a set of values for the variables that makes all the equations true. So the first one we're going to look at is we're going to look at graphing. So we're going to graph these. Well, I'm going to actually solve them into y equals mx plus b first. And so on this top one, I'm going to go 2y equals 3x plus 8. And then I'm going to divide by 2. So y equals 3 halves x plus 4. And then on the second one, I'm going to bring my x over. So I end up with 2y equals negative x minus 8. And then y equals negative 1 half x minus 4. So I'm going to graph these. Now, honestly, graphing is a great way to visually represent those. It gives you a good idea of where it's going to be. The problem with graphing is that you will, a lot of times, get in some error. So because here's my graph here. I hand drew this graph. Even if I had a graph paper, there's a high likelihood that I would actually incur some error. So the first thing I'm going to do is I'm going to graph the black one. So I'm going to go up 4, 1, 2, 3, 4, and then I would use my slope, okay? I'm actually going to use the reverse of my slope, so I'm actually going to go down 3 over 2, down 3, 1, 2, 3 over 2. Okay, so there's my next point there, and I'm going to just kind of draw those in, kind of keep it in there. Now I'm going to graph my orange graph, so I'm going to go down 4, 1, 2, 3, 4. I'm going to kind of go backwards. I could go down 1 over 2, but I'm going to go up 1, left 2, up 1, left, up 1, oh, up 1, left 2. Okay. And there's my graph, and it looks like I'm off a little bit. This actually should be at 4, negative 2, and this is why you can kind of see. So my distance up here is actually farther than the distance down here, so I've incurred error. But our graph should be negative 4, negative 2. That would give me my point of intersection. So the next thing we're going to do is look at a table, and I've already kind of filled out the table just because to save time. So here's my two equations, and this is charting the growth of two different types of sharks. So one of them is born at 37 inches, I believe, or centimeters, and the other is at 22, and then they grow this amount. So when are they going to be equal? So we started off, and I plugged in 0 just to kind of show you that initial length there on our two sharks. And then I said, well, what would happen after year 1 to just get an idea? Well, this one's going to add 0.75. This one's going to add 1.5. They're still pretty far away. So I'm going to jump. Instead of going 2, 3, 4, I'm going to jump up to 10. So I put 10 in here. That gives me 7.5, and that gives me 37, so 44.5. Here I have, I added 15, which gives me 37. So I'm pretty close here, but I'm still pretty far away. So I'm going to jump another 10 to 20. And when I put in 20, I see that we have 52 and 52. So my answer to this would be 20, 52. So at 20, we're going to have 52. Now, the last thing we're going to talk about in here is kind of classifying these. Well, two lines can intersect one of 3 ways. They can intersect once, so that's consistent, independent, one solution. So the way we determine if they have one solution is they have different slopes. Okay, as long as they have different slopes, they're going to have one solution. The next is when I have two lines that are overlapping each other. So it's a line on top of a line. So it's really the same line. So that's called consistent dependent. There are infinitely many solutions. Okay, so the slope and the y-intercept are the same. So they are the exact same when you simplify these equations, they will be the same equation. And then we have inconsistent. So inconsistent means there's no intersections, they have no solutions or zero solutions. They are parallel lines, so they have the same slope and a different y-intercept. So here it says classify. Well, I have one in standard and one not in standard. So a lot of times the easiest way to look at these is because notice here this one we have to have different slopes, this one we have to have the same slopes, same y-intercept. Here we have to have the same slope and different y-intercept. So what I'm going to do is I'm actually going to convert these into y equals mx plus b. That way I can see the slope, I can see the y-intercept, and determine it. Okay, so I'm going to start with the first one. So I'm going to add my 2x over. 4y equals 2x plus 6. I'm going to divide by 4. I have y equals 1/2 x plus 3/2. I'm going to take my other equation here, and I have 8y equals 4x minus 12. I'm going to divide everything by 8. And I get y equals 1/2 x minus 3/2. So I look here. My slopes are the same, okay? My y-intercepts are different. Well, what has the same slope and a different y-intercept? That's inconsistent. So these are inconsistent, okay? Just telling me that they're parallel lines and there. If they had the same slope, but same intercept, then they would be consistent dependent. So that's starting off systems of equations where we actually will solve it using a graph and a table. Be careful with graphing because it's very easy to incur error.